Hey everyone, so it's the second class for us. I hope everyone was able to make an account on Lumen and enroll in the class, because again, that's where the homework and quizzes will be. If you were not able to do that, please, contact me. I am able to help you, okay? And I want to help you if you need it, okay? I also emailed an outline of today's lecture notes, so, hopefully you have those. Okay, so that said, I was trying to think if there's anything else. I think that's it. If that's said, let me get started with today's lecture. Now again, with the homework, there will be homework starting next week. So, please make your account, okay? All right, so let me stop sharing my camera. Okay, now get to this. Okay. Okay, so let me start the lecture. Okay, so now, let me see, is everyone able to see this? Yeah, okay, good. Okay, all right, so again, this is what we got up to last time, okay? So last time, if you remember, we got up to the set of integers. Now, with the set of integers, remember, basically what we did, we had the set of natural numbers, which are the positive integers, okay? The natural numbers. What we did was we took that set, we added 0, and we added the negatives. The negative integers, that is. And we have this ... notation, mostly to indicate that the pattern keeps on going. So for instance, before -3, you would have -4, -5, -6, and so on. After this 3, you would have 4, 5, 6, and so on and so forth. I did rewrite the set a little bit differently. Namely, what I did was I rewrote it as 0, 1, -1, 2, -2, and so on and so forth. So after -3, you would have 4, then -4, and that's basically the set of integers. That's a good set. And from that set, we can form what's called the set of rational numbers. It's denoted by this funny looking Q, and this is the set of all fractions of integers, which as you can see from here is the set of all rational numbers. And again, this is the set of all numbers of the form P over Q, fractions, where P is an integer, Q is a non-zero integer. So P and Q are integers, but Q cannot be 0. You never divide by 0. And that's what the set of rational numbers, that's what that set is. Okay. And you could consider the decimal expansion of these numbers. We're not going to cover that for time consideration. Now, not every number out there is in this set. In other words, there are many numbers out there that cannot be written as one integer over a non-zero one. Those numbers are called irrational numbers. So irrational numbers are numbers that are not rational. Okay? So again, irrational numbers are numbers that are not rational. I thought someone raised their hand, that's why I looked here. So let me go back to this. In other words, they're numbers that don't belong in the set Q. They're not in that set. And there are many numbers that are irrational. If you remember The formula for the area of a circle or the circumference of a circle, there's that pi in here, right? Pi represents actually a number. The number it represents is irrational. I'm not sure if you know about the number that E represents. I mean, you might, but it turns out the number that E represents, it comes up in applications, it comes up in calculus, that turns out to be irrational as well. And there's other numbers also. I mean, we will get to the square root later on, but the square root of 2, the square root of 3, they turn out to be irrational. Although why they're irrational, why they're not rational takes a little bit of work, but that's a different story. We also have, all the numbers out there that are rational or irrational. So all the numbers that are rational or irrational, those numbers are called real numbers. This R here denotes the set. So this R here denotes the set of all real numbers. That is, all numbers that are either rational or irrational. Really, for us, this is going to be our playground, so to say, of numbers in this course. These are the kind of numbers that we're going to be dealing with. Now, the book does go a bit into the set of complex numbers. And by definition, this set is the set of all numbers in this form, a plus I times b, where a and b are real numbers. So a and b are numbers that are either rational or irrational. I is what they call an imaginary number. It's the square root of -1. In other words, I is the number whose square, that is, if you square it, if you multiply it by itself, you get -1. No real number pulls that off, but we're imagining some number that does that, so to say. But again, the complex numbers, for time consideration, I haven't really gotten into that. So I'm just mentioning what the complex numbers are for now. All right. Are there any questions about this? Okay, I said this for the other class with the textbook. Again, I am in the process of getting a copy of the 4th edition, because that's what the bookstore is selling. I only have the 3rd edition with me. I mean, I could post practice questions from the 3rd edition. It's just that from the 4th edition, I don't know how much of a difference there is. But again, I am in the process of getting the 4th edition. So just, giving everyone a heads up. Okay. All right, so exponents come up when we multiply. Namely, for any real number a and any positive integer n, or if you want natural number for us, by definition, a to the n is a times itself n times. In other words, you have n copies of a, whatever that number a is, whatever a represents. You have n copies, and you're multiplying them all together. You're multiplying them all together. And this is part of the definition that a to the first is just a. This also indicates that when the exponent is 1, we really don't have to write it, and we don't write it. So if you see a number with no exponent, the exponent is understood to be 1. Okay, here's some more terminology. A to the n, by definition, we say is the nth power of a. It's the nth power of a, and we also read it as a to the n, or a to the nth power. The a here, we call it the base. The n is the exponent. And I threw in some examples here. Again, this section I'm treating as review, so I am going a little bit quicker than than I will with the other sections that we see in the course. And I'm also doing less examples. 4 is 2 times 2, which we know is just 2, which is just 2 squared from here. 81 is 3 times 3 times 3 times 3, which is 3 to the 4th, right? 4 copies of 3, we're multiplying them. That's what we're doing here. You do have to be careful with exponents, though, especially when the base, when the a, in other words, when the a here is negative. You have to be extra careful, and that's what this slide is showing you. Namely, minus 3 squared, right? Well, by what we just saw, this is equal to minus 3 times minus 3, which we know is 9. By our sap and sun rules, I think they call it. Sap meaning signs alike, the answer is positive. Sun meaning signs unlike, the answer is negative. So that's what minus 3 squared is. Minus 3 squared, though, here, this is minus 3 times 3, which is minus 9. And that's not the same as this. This is not the same as this. So what am I getting at? Well, these two are not equal, as you can see here, as I wrote here. So if the base, if your a is negative, you have to use parentheses carefully, mostly because of the negative sign. You have to be careful is what I'm saying. When the base is negative, when the a is negative, the base, that is. Okay. Yeah?
Quick question. Would the negative sign ever be on the outside of the parentheses?
It could. This is, here, you know what, that's a good question. Let me write down, actually. From here, the minus 3 squared, this is actually the same as minus parentheses 3 squared.
Okay, thank you.
You're welcome. Very good question. This is the same thing as this.
Hi, I have a question.
Okay?
So you're just telling us to be careful, like if we do something like this?
Exactly, with the minus signs. That's all I'm really trying to say here.
Okay, sounds good.
Okay, good. You're welcome. Any other questions?